Right, so what's happening, we're still going to do problems that are like this involving finding the range, but this time, just as I gave you this warning that to use the range equation, it had to start and stop at the same height, I'm going to do one now that is different heights. So that's what I'm training you to do, because when we throw the water balloon out the window, launch it out, is it going to end at the same height it started? No. So we have to to do this lab, we were going to have to know how to do that. So let's draw something on a cliff, let's say a cannon. And this cannon is going to launch a cannonball, and the cannonball is going to come out horizontal. It's important to realize when it leaves the cannon barrel, it's going to come out exactly horizontal. What degrees would that be? 0. So it's going to come out at 0 degrees just for an instant, and then,
It's not very complicated.
So let's say that we happen to know the distance from the cannon launch, so up here, to the bottom. We'll make it an even number. We'll say it's 100.0 meters. It's a pretty tall cliff, actually. 100.0 meters. And we'll say it's launched with an initial velocity of 150 meters per second. And I don't have to tell you the angle because you just told me the angle. If you want to write it in for emphasis, you would write, this won't be given, but for the first one, the angle is 0 degrees. All right. So the question is, how far from the cliff, from the base of the cliff, that's a question in orange. I'm going to lose my colors. Question in orange today. Orange, orange, orange. So how far from the cliff? So this is still a range question. So what is the range of the cannonball? How far from the cliff did it land?
Oh, that's why, because I did, okay.
When I say how far from the cliff, I mean the base of the cliff. So I don't mean like from up here to here. I'm talking about how far from the base of the cliff. So I'll say from the cliff base.
Do you have a new piece of paper for this lesson?
This is still in the range. It's still on the lesson on range. So we're just going to keep on.
I don't have any more room.
You can use the back. It's fine.
I don't have any more room on the back either.
All right. Grab a piece of paper and make sure it's always behind that sheet because it's related. All right. So let's start. Is this a question in X or a question in Y, class? X or Y are we working in? X, because we want to know this distance. It's definitely horizontal, so we're working in X. So we're going to write down our big 5, all in X. And if the bell rings before we finish this, that's fine. We'll pick it up right where we left tomorrow. I'll finish one of these and then we'll proceed to the window to do one in real life.
Do you
So,
want us to do these, the 5
And there's 3
which are the 5, yes. All right. All right, it's the same as the 4 point, same as the OYOs.
Finish the 4.5 to 4.7.
Oh, you did, and they're correct?
Yes.
Okay.
The other ones are really fast.
Yeah. Alex, did you finish the OYOs?
Yes, for the last one.
One more, first two, okay. All right. The velocity in the X direction, we're going to look for that first, and it is going to be 150 cosine 0. Like it is in any problem, we always use cosine for the x1. And notice the velocity final is going to be the same because the velocity never changes in the x direction. So now the acceleration in the x direction, class, is, everyone, what's this acceleration? What? Acceleration in the x direction.
It's always 0.
Right, because the velocity never changes. So it is 0. The time, do we know the time? We know nothing about the time. And we're looking for the range. So, if we pull out any equation, they're all going to fail us, but one will get us a little further than the others, and that's this one, the voter. So, we're looking for x in the x direction. The initial velocity, what is 150 cosine 0? Cosine 0, 1, so it's 150. And the 0, this term zeroes out because the acceleration is 0. So we ended up with x equals 150 times t, and we hit the dead end. So just like before, where do we go to get time? We go over to the y land, so I'll pick up my blue, and we're going to do the same sort of Hoostruck with the blue in the y direction. And I think that's a good stopping point. So we will pick it up there. If you would, clean up your area and pack up. The bell's about to ring.
Bye, Brett.
Brandon, I'll catch you later.